All right. So our next section, moving on to 1, 2, 1. So chapter 2 or chapter 1, section 2, topic 1. We're going to be representing some functions. Whoops.
I went through so much over it.
I apologize.
No, I don't really care. I'm just saying.
So we're going to spend a good chunk of time on today's lessons on going over those trigonometric functions that I know you guys loved in geometry class. So we like to use those trigonometric ratios when we need to find like missing angles. So for finding missing angles and or sides of a right triangle. And last year in geometry, we kind of gave you guys that Sohcahtoa to use as a reference. You guys remember Sohcahtoa? Yeah. But you remember like something about it, right? Right. So, and we'll go through all of these today. See, it's coming back to you. I know it takes a little refresher, right? So the trigonometric ratios that we're going to kind of focus on is sine, cosine, and tangent. And then we kind of look at them within a nice little triangle. So let's say we have a cute little right triangle. And we know it's a right triangle because it has that little box in the corner, right? And when it comes to that Sohcahtoa, we always went off of an angle. So I'm just going to throw theta down there at the bottom just so that we have an angle we can talk about. So when it comes to Sohcahtoa, it's always looking at like those opposite, adjacent, and hypotenuse sides of a triangle. And we always go off of the angle that either we're looking for or the angle that they give us. So we need to start by figuring out what side of the triangle is opposite, which one is adjacent, and which one is a hypotenuse. So we always go from the angle. So like we're talking about theta, right? So let's see if we can find the opposite side. So the easiest way I just think of it is wherever you are for that angle, you're going to the opposite side of the triangle. So you'd be coming all the way over here. Is that coming back to you? Yep. So this would be our opposite side. Can you guys always find the hypotenuse? Yep, it's across from the right angle, and it's also the largest side, right? So it's always going to be across from there. So that one's going to be our hypotenuse. And then our last one is adjacent. So from this angle, this one is our adjacent side. So you guys know I'm cheesy. So like when I was in high school, there was this kid named Jason, and he was cute, and I wanted to sit next to him. Adjacent, next to? No?
No, I don't know about that.
I tried.
Yeah,
I tried.
yesterday was good.
Yeah, well, you win some, you lose some, right? All right. So let's see. So when it comes to these, if I'm talking about like sine, it's always going to be from the angle. So our angle was that theta, right? And so sine is that opposite over hypotenuse, right? Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Some people write Sohcahtoa. They'll actually say like sine is opposite over hypotenuse. Right? Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Did you guys see it this way last year? or don't remember? Both ways, yeah, yep. All right, so let's try kind of a cheesy little example of these, right? So I know you guys think I draw beautiful right triangles, and I appreciate that. Right? I try. Perfect, right? So we know it's a right triangle, even if it doesn't look like a right triangle, because it's got that little square in the corner, right? And I'm going to stick with that little theta, just because I like making little thetas. And I'm going to say this side is 3, this side is 4, and this side is 5. So I just want to go through and be able to write out all of my trig ratios. So I need to figure out which one is at what side is opposite, adjacent, and hypotenuse, right? So I'm going to go from the angle that I know something about. So I'm going to go from this angle. So what's my 4 going to be? Opposite, adjacent, or hypotenuse? Yep, opposite. Yep. My 3 is going to be adjacent. And my 5 is going to be hypotenuse. So if I wanted to find the sine of theta, right, so I got our Sohcahtoa. Oop, running out of room over there. So sine is opposite over hypotenuse. So which one's opposite? Which one's hypotenuse? 5. Yep. If I want to do the cosine of alpha, cosine's adjacent over hypotenuse. Which one's adjacent? 3. What's hypotenuse? 5. Look at you guys. You guys are some rock stars. Tangent of theta. Tangent is what over what?
Opposite over
Adjacent. Yep. Opposite is 4. Adjacent, or sorry, yeah, adjacent is 3. Right? And if we wanted to, we could look at that same triangle again, that exact same triangle, right? This was 3, this was 4, this side was 5. But maybe I change it and I want to look at the angle up there. So we call that beta, little Greek letter. It's just got a little tail down for the bottom. So I can do the same stuff, but my sides are going to change, right? If I look for those opposite, adjacent, and hypotenuse, my 5 is still going to be the hypotenuse, right? That's not going to change. But now my 3 is going to be what from beta?
opposite.
Now that one's my opposite side. Yep. And 4 is going to be my adjacent. Right? I know. Just think adjacent, right? Halloween's coming. You want to be next to him. So now if I go through sine of beta, right? Sine is now going to be opposite over hypotenuse. What's opposite? Yep. And what's hypotenuse? 5, right? What's cosine of beta going to equal? Yep. And tangent of beta, right, yep. And tangent of beta is going to be 3 over 4, 3 over 4, right? Yep. So if we look at these, like our sine of theta and our sine of beta, we're going to get different measurements, right? Because we're looking at it from different angles. So we got to make sure that we're always going from the right angle to find out our sides, because it's going to change depending on what side or angle we're looking at. All right, ready to try some legit problems with these? All right. We got a little right triangle. I'm going to say this bottom one is 19 centimeters. I'm going to say this guy over here is X, or X centimeters. And the angle at the bottom is going to be 22 degrees. Right. So we use trig ratios to find missing angles and missing sides, right? So we have that x is our missing side. Could we use Pythagorean Theorem to figure out the side? Remember Pythagorean Theorem, a squared plus b squared equals c squared, right? So to use Pythagorean Theorem, though, we need to know at least two sides. Do we know at least two sides? No, we don't know anything about this side over here, right? So we can't use Pythagorean Theorem. So we have to use one of the trig ratios. So we always go from the angle that we know or that we're looking for. And so we got to figure out what two sides we have. So what's my x going to be? Adjacent, opposite, or hypotenuse? Yep, that's your hypotenuse. And then from this angle to get to that 19, that's going to be my adjacent. Yeah, whoops. Adjacent. So if we go back to our Sohcahtoa, what is it? Oh, the squirrels. Yeah. Just don't feed them. Right. All right. So we have adjacent and hypotenuse. So if we look at Sohcahtoa, which one has to do with adjacent and hypotenuse? Cosine. So we know we got to use the cosine ratio, right? So we have the cosine from which angle?
Are we gonna get like a paper we can write down? So we're just gonna have to remember. Like last one geometry, we got like a.
You just got to remember Sohcahtoa.
No, like for like test.
Sohcahtoa.
And all we have to remember for the whole test ever given.
Well, if you're talking about trig, yes.
Yeah.
Yeah. We just the math department said no reference sheets this year. They said that if it's a formula that you need to know, like, and it's not one that you're expected to have like memorized, like we should know like slope intercept y equals mx plus b now, right? But if it was some crazy formula, like, so we're going to get into the laws of sines and cosines. You don't have to have those ones memorized. We'll have them on the test for you, but it won't have every single possible. Like, so when it comes to trig, like the Sohcahtoa, like you guys should know Sohcahtoa by now. So in geometry, you probably got it because you were getting introduced to it, but now it's kind of like you've seen it more often. So
We have to take 4 years in math.
yes. Yep.
Dude, I don't even need this.
All right. So we have the cosine from our angle. And what's the angle that we know? 22 equals adjacent is, yep, over x, right? So now it just kind of gets into like how you personally like to do your algebra problems. There's two ways you can kind of approach this. A lot of times we'll tell students to throw this over 1 so that they have those two fractions that are equal. So that way they're proportionate, they're ratios. So we know that if we multiply denominator times numerator, it's going to equal numerator times denominator, right, when you cross multiply. The other thing you can do is anytime you have a fraction and you want to get rid of the fraction, you always multiply both sides by what's in the denominator. So you like multiply both sides by x, right? So we'll kind of go back and forth between the two different ways. You don't have to do it the way that I do it in the notes. If you're comfortable doing it whichever way you want to do it, by all means, you do your math, right? All right, so we're going to say that we're going to throw it over 1. So we got two fractions that are equal, so they're proportionate. So we know that the numerator times the denominator is going to equal the numerator times the denominator, right? So what do we have? X times the cosine of 22 equals 19. And if you guys remember when you guys were talking about these even in geometry, that cosine of 22, that's not the cosine times 22. That's a number, that's one number. Cosine of 22 is a number. So sometimes we tell students to throw that in parentheses so that they know that it's just one number, but you don't have to. And our goal is to get x all by itself because we all want our x's to be by themselves, right? So almost, you can't put it in the calculator until you get x all by itself, and then we're going to put it in the calculator. So we got to get rid of that cosine of 22 on the left side. Anybody know how we can get rid of it?
Do it on calculator.
Jesus.
Divide both sides by the cosine of 22. Because that cancels all of this out, right? So now you got x equals 19 over the cosine of 22. And I don't think any of us can do that in our head. So then that's when we get our fancy dancy handy dandy little calculator. So one thing you can do is you can go to my website at bit.ly. Hold on. Oops, I gotta get these guys out of the way. And if you go to resources, under resources, it listed all of this. We don't need the graphing calculator to do this. There's a Desmo scientific calculator, and you can just click on that and it pops up. So for our problem, so here's your sine, cosine, and tangent. Or you can get to it if you hit the function button. It'll give it to you there, sine, cosine, and tangent. So we want to do 19 divided by the cosine of 22. Only thing we need to make sure is that our calculator is in degree mode. Most all calculators default to degree mode, not radians. Once you get into trig pre-calc, and yeah, we don't do it in algebra 2. So trig and pre-calc, we'll sit there and switch that over into radians and do some stuff. So most of the time your calculator should always be in that degree mode anyways. But one way to kind of check on it is, say I do this problem and I end up getting a negative number. This 22.5 for our answer, was it 22.5 or 20.5? 20.5, yep. That's the length of the side of this triangle, right? Could that ever be negative? No, because you can't have negative 20.5 centimeters, right? So we know that that's always got to be a positive number. So if you end up getting a negative number, a lot of times it's your calculator's in the wrong mode. It's in actually radians and not degrees. But usually you don't have a problem with it. All right. Want to try another one? Sure. We got a right triangle. Let's say this side is x inches. We got a 30-degree angle. Oops, let me clean that up a little bit. 30-degree angle, and this side is 26 inches. So again, we can't use Pythagorean Theorem because we don't know 2 of the 3 sides. So we got to use one of our trig ratios. So we just got to figure out if we need to use sine, cosine, or tangent. Sine, think so. So from this angle, I know opposite and I know hypotenuse. Yep. So opposite and hypotenuse is going to give me sine. Good job. So we know we get the sine. So what angle did we go from? So the sine of 30 equals opposite over hypotenuse. This problem, or is there a?
Yeah.
Yeah, the inverse?
Yeah.
Yep. That's next. Yep. So on this one, we can write it as the fraction and you can cross multiply. Or the other option is you multiply by what's in the denominator. And what do we have in the denominator? 26. So to get rid of that 26 out of the denominator, you would multiply both sides by 26. right? Because anytime you have an equation, if you do it to one side, you got to do it to the other, right? So now I have 26, and I'm going to throw it in parentheses just for the fun of it, right? And then these are going to cancel, and then that gives me my x. So the one thing we got to be careful about is remember that sine of 30, that's one number, right? So this isn't like the sine of 26 times 30. That's a no-no, right? This is a number times 26. So we're going to go back to our fancy little calculator. And we're going to put in 26 times the sine of 30. And what do we get? 13. Yep. Oops. So our x is going to equal 13. So we know it's 13 inches. So what if we don't know the angle? We could always run into a problem like that, right? We got our right triangle. Let's say it's x degrees, and we know this side is 2.7 feet, and this side is 5.5 feet. Yep. Pythagorean theorem doesn't help us because we don't want to know the side, we want to know the angle. So we got to figure out if we're using sine, cosine, or tangent. So from our angle, we have this one and this one. What are those two going to give us? That one's opposite, that one's hypotenuse. So that would give us the sine. So the sine of what angle? So that's the sine of x equals 2.7 over 5.5, right? So technically we need to get our x all by itself. So, but the problem is that x is with that sine, and that's one number. So we got to figure out how to get rid of the sine so that we only have the x. So this is when it comes to the inverse. Anytime you have a number and you multiply it by its inverse, they cancel each other out. So technically, you're doing the sine inverse of sine x equals the sine inverse of 2.7 over 5.5. So anything times its inverse is 1, so that makes that whole piece go away. So that's how you technically get your x all by itself. So the inverse is 2.7 over 5.5. Then we can pull up our handy dandy little calculator again. So if you have like the regular scientific calculator or the graphing calculators, you're going to use that second button, like second sine, and it'll take you to the inverse. If you're using the online one, you got to switch over to that function, and then you'll see the inverse. So then it was the sine inverse. And what did we have? Oops, you got to go away. Uh-oh, hold on. 2.7 divided by 5.5, and we get 29.4. So we know that it's 29.4 degrees. I know you guys are all big fans of trigonometry. Love the little triggy-wiggy functions, right? So I just want to go over real quick with you guys. I know we talked about it last week or the beginning of this week. They're all running together already. When we were talking about X and Y intercepts. So if we need to find X and Y intercepts, So by definition, what's an x-intercept? If we had a graph, what's x-intercept mean? Yeah, it's where we cross the x-axis, right? So it's crossing this guy. And we talked about it last week. When we cross that x-axis, we know that our y value is always going to do what? What's it going to equal? Our y is always going to be 0, right? And just the opposite, if we were talking about our y-intercept, can't spell today either, I guess. If we're talking about our y-intercept, that's where we're crossing the y-axis, right? And if we're crossing the y-axis, our x value is always going to equal 0. So our x equals 0, right? So in your guys' assignment, you're going to get this funky equation. So let's say we have like 7 equals 2x minus 5y. And they want you to find the x and the y-intercept. So granted, you could go through and solve it for y and graph it and see if you can find the x and y-intercept. Or you can do it using a little bit of algebra by using what we know about the x's and the y's being 0. So if I want to find the x-intercept, I know that my y value is going to equal 0. So I'm going to take my equation and guess what I'm going to put in for y? I'm going to put in 0. So then we're going to do a little algebra. What are we going to get? 7 equals 2x. So my x is going to equal 7 over 2. Could we simplify that if we wanted to? What's 7 over 2? 3.5, 3.5, right? When they want you to find these x and y intercepts, they want you to find that point that they cross over the x-axis or over the y-axis. So we got to find the point. And a point is made up of an x and a y coordinate, right? So to find our x-intercept, the x value was 3.5. And what was the y value? What do we put in for y? 0. So it would cross at the point like 3.5, 0, right? That shows like where it crosses the x-axis. So then you got to do one more, and guess what one that one's for? For the y-intercept, right? So if I want to find the y-intercept, what am I going to do? Put 0 in for x. 2 times 0 minus 5y. So what am I going to get? 7 equals negative 5y. Yep. So negative 7/5, oops, equals y. So I just got to find that point, right? So for the y-intercept, my x coordinate is going to be, what do we put in? 0. And what's my y going to be? Negative 7/5, right? And if I wanted to put that on my little graph, so a negative 7/5, what's that? Like 1 and 1 point, negative 1.6-ish, right? So that's going to be like right about there, right? My x was 0. Oops. So that would be like the line. But we didn't need the line. We just needed the x and the y-intercept. You guys got any questions on those? No? All right.